So you have already know about the data communication, about the network, right? Anyone can define the network? What is the network? Hello? You know, do you know about how we can this WDM network is useful in current scenario? What the need to read the subject? Anyone can tell? हेलो, बच्चों कुछ बोलेंगे नहीं तो कैसे वर्क होगा फिर? स्क्रीन इज विजिबल?
Yes, sir.
ओके, थोड़ा सा प्लीज पार्टिसिपेट कीजिए, तब देन यू कैन अंडरस्टैंड, राइट? सो द टॉपिक नेम आई एम राइटिंग हियर, यू सी WDM. Okay, because after long time I will start this board. So draw, insert, drawing tool. Okay, so this is the subject name is WDM optical network, right? And the course code is EC22103, right? So what I want to convey here, first we understand what the need of WDM optical network, because if you see carefully, because first of all we already have a digital communication, right? Digital communication already we have. Then in the sixth semester, I think you have studied about optical communication, right? Optical communication. And then in the next, in the seventh semester or eighth semester, you are reading about the optical network. So this is the sequence actually, if you see carefully. So I think one more thing here before to start this contents equally, I think your mid semester examination on the next week start, I think, right? So contents of the syllabus, first I share you the contents of the syllabus for the mid semester examination, right? And then I'll start this all the things. So dear students, I have shared you the one book, right? And that book is the, I think this one. Oh, yes, this one book I have shared you. So first you note down your examination point of view contents, right? For the mid semester examination. So this book I have already shared you. Okay. So in this book, you write down some questions, right? What is the need of WDM network? हेलो बच्चों, थोड़ा सा प्लीज, आप लोग
Yes,
यही
sir.
हैं फिर भी?
Yes, sir.
हाँ, ओके. What is the need of WDM network over the optical communication and digital communication? Number one. Number two, if you see very carefully the contents of right, if you see very carefully contents of yeah, this one, page number 45 of this book, propagation of single end optical signals in optical fibers, right? So these contents means chapter 2 already you have studied in the BTech, you can say sixth semester or fifth semester. You see these contents, you have already studied all these things. So chapter 2, right, up to the 5.9, 2.5.9, up to this point, you have already studied in the previous semester. So chapter 2 is the complete one for the mid semester examination. Okay. Next is the what is the light path? Next question. You can note down this 45 number page and chapter 2 propagation of single signals in the optical fiber. So this one contains whole contents, and then next content is the what is the light path? How it is useful for the WDM network. Next question. What is the light path and how it is useful in WDM optical network, right? And then next question, how the how is optical network is work? What is the working principle, or you can say what is the working principle of WDM network? Okay, and next one more thing, and what is the difference between the circuit switching, packet switching, because already you know in that read in the digital data communication, and which type of the switching we prefer in optical network and why. The answer is similar like a data communication. Okay, I am repeating again the question. How many type of the switching, and what is the difference between the circuit switching and packet switching, and which one switching we prefer mostly in the optical network. Now these are the contents for the your mid semester examination. Now I am start the syllabus and point by point. Okay, now you see. So dear students, if you see in the, because it's my first class, so WDM first I'm trying to explain you what is the need of WDM optical network, right? So digital communication, right? So we have a normally two type of the communication, wireless or wired. And this optical network actually the category of the wired communication. Note this point, right? Category of the wired communication. So normally in the digital communication, we use the all the modulation techniques like most frequently nowadays we are using QAM, QPSK, right? With metals, right? Means with metal means because for any communication you required a transmitter, then you required a channel, then you required a receiver. So dear students, normally means in before 1990s we have a channel. This is made from the metallic, right? Metallic wire. Like what's the metallic wire? Like a coaxial cable, like a transmission line, like a strip line, like a micro strip line. All these all contents or twisted pair cable. Nowadays, still we are using twisted pair cable in our telephone connections. Okay, so all these channels actually made from the metals. And metal, when the signal is propagating inside the metal, and this offer a around 20 dB per kilometer loss, right? And as you know, suppose you want to the long haul communication, right? Then what is happening? If you apply the signal, then signal exponentially decay inside the channel. Okay. And now suppose you require to transmit from Allahabad to Lucknow, suppose. Okay. And this is the channel around 200 kilometer. And you assume that this metallic wire actually, so you having a loss of 20 dB per kilometer, right? 20 dB per kilometer. This is I am writing. So it meaning that you required a too much huge power at a transmitting end, right? Because you need to cover 200 kilometer. Now suppose, and also one more point here, because in the digital communication we use the repeaters or regenerative circuits, you can say. And if you use the metallic channels, right, like a coaxial cable or twisted pair cable or micro strip lines, then you require a repeaters at a distance of 30 to 40 kilometers, because the loss in the metal is like a 20 dB per kilometer, right? Because for any communication, right, we require two, three things main parameter. One is the should be minimum loss. Number two, should be high speed. Number three, should be good BER. Good BER means improved BER. So the distortion of the signal should be low. So these are the 3-4 points which is required for a good communication. Now if we talk about, means you can say in the digital communication, if we use have a in 90s, I am talking about the 90s era, and then you have a metallic wire. Then what is happening? Indian government doing what is doing? They replace only this channel, metal channel, by the optical fiber, optical fiber, and other rest of the things are similar. Optical fiber with electrical to optical converter and optical to electrical converter, means electrical to optical, optical to electrical converter. In 90s start, Indian government start replacing coaxial cable, all these metal channels, by the optical fiber. And optical fiber, this is offering a 0.2 dB per kilometer loss. Now you can compare the loss around 10 times, you can see. So what is happening? This repeater distance or regenerative circuit distance is increasing by 120 to 103 kilometer, 130 kilometer, means that repeater or regenerative circuit. Yes, students, I also tell you the difference between the repeaters and regenerative circuit. Repeaters actually having only the amplification, and regenerative circuit having the amplification with some signal processing unit, and function of the signal processing unit, it having a equalizer. So you, for this signal processing whole unit is required to free the distortion from the signal. Okay, so this is the difference between the repeaters and regenerative circuits. Now you see what is happening when you use the optical communication. Then the optical fiber having a 0.2 dB per kilometer loss, and distance, repeaters distance is 120 to 130 kilometer. One more point here, because optical fiber is made from the dielectric material, means simple silica. You can fabricate with core and cladding by the some doping. Okay. Another point here, normally digital communication, we are talking about, for example, nowadays, right? For a wireless communication, you can say, we have maximum data rate about the 5G or 6G, 1 Gbps only. 1 gigabit per second, the maximum data rate actually. If we talk about the optical fiber, then we are around 112 Gbps data rate. You can understand the difference. What this is optical wired, okay? And if you take here this data around the wireless, but if you take the wired also, then you are not having the more than 5 Gbps data rate. Not is possible. But you can compare the optical communication, right? So dear students, what to do in 2005 around, right? Indian government started the WDM concept. I'm talking about an Indian standard, right? WDM concept, okay? And utilizing hybrid mode. Hybrid mode, what is the hybrid mode? Hybrid mode meaning that we have a RF with optical. This is the hybrid. Anyone listening me or I am just talking? Hello.
Yes, sir.
Yes, sir.
Okay. Okay. Thank you. Now you see. So in 2005, India started the WDM concept in hybrid mode. Now you understand what is the hybrid mode here. Actually, now you see current scenario. What is going on in the current scenario? And you see, suppose we are here and a small portion. Suppose this is the Allahabad center. Suppose, right? And this is the, suppose, uh, Delhi, suppose. Okay. And this distance is around 614 kilometer. Okay. And suppose you are in the MNIT campus. So this is suppose MNIT area, right? And suppose you want to communicate at NIT Delhi. So this is the NIT Delhi, suppose. So in every city, right, we have our main telephone exchange center, right? And nowadays we have be like a BSNL office, you can say main. Suppose it's the main center of the city, right? And this is suppose main center of the city at Delhi side, at Allahabad side, right? And this is the optical fiber, right? Now now suppose you are, because nowadays most of the means 90% people prefer the mobile communication, right? So obviously, mobile range means tower, your signal, mobile signal can reach up to the 1 to 2 kilometer maximum range for a wireless communication. So suppose you make a call to your friend at NIT Delhi. So suppose nearby tower at your location, suppose this one is at location, and this distance from MNIT to this tower is 1 to 2 kilometers, suppose. Then what happening here? Mobile having a antenna, microstrip antenna, it's radiating the energy, and that energy reaches such nearby the antenna tower. And suppose this tower nearby the 1 to 2 kilometers searching this tower, and this tower also having a antenna, dear students. So this receiving a signal, so means from, suppose this is the A point MNIT, or this tower is the B point. So A point to B point, we having a RF communication, means radio wave communication. Okay, and domain is electrical domain. Now this tower having a device, this is known as the E to O converter, means electrical to optical converter. Then this tower convert electrical signal into the optical signal. And suppose this is the tower, I tell you, this is the suppose tower, and this tower having here E to O converter, right? And at the top of the tower, I tell you this point, right? The device at the top of the tower where the signal received, and then this fiber, right? Then this means converting you are in optical nature. So now from this tower to this main telephone exchange, we connect through the fiber cable only. So you see, what is the hybrid here? A to B, you have RF communication. But suppose this is the tower C point, suppose, or this main telephone exchange, suppose D point. So C to D, you having a optical wired. Here RF wireless. This is the current scenario. So A to B you have RF wireless, C to D you have optical wired. So this is the nature, hybrid nature, means you have wired with wireless, and you having a RF with optical. So electrical, RF means electrical. So electrical and optical. So this is the nature actually, current scenario. Now what is happening? At main center of the telephone exchange, it receives the signal, and again it reprocesses, and after 2005 they have optical switching and routing. Before that, we just 90s to, in 90s to 2000, we have only the E to O converter or O to E converter and fiber cable. Means switching and routing be performed in the electrical domain only. Now, after 2005, we can perform in the optical domain as well. So now we perform all these things, then this fiber cable with some repeaters, because as I told you, after 120 to 30 kilometer, you arrange a repeaters for maintain the loss inside the fiber cable. And then this signal reaching at a Delhi at main telephone exchange. Again here signal processing is performed. And then suppose a nearby tower at NIT Delhi, this is tower, and each and every tower in every city, right? Listen this point very carefully. Each and every tower in every city connected through fiber cable to main telephone exchange. Every city. Now this obviously this cable, this tower also connected with main telephone exchange, and then suppose the signal reaching by the fiber at the tower, nearby tower of this, and then this tower again have a O to E converter. This is the transceiver type things, means it is the inherent, it can work as optical to electrical as well as electrical to optical. Now this reaching at nearby the mobile user tower, and then again this communication taking place in the wireless. So this is the current scenario in India. We are moving, and this technology in India we are known as the SDH technology, and this is full form is the synchronous digital hierarchy. We are every BSNL offices or telephone exchanges having this technology. Normally, for a networking point of view, we have two technologies. One having a name is the SDH, and another name is the Sonnet optical. Sonnet. So yeah, synchronous optical network. S means synchronous, O means optical, NET means network. So these are the basically two parallel technology. One use SDS use India, right, and European country. Sonnet use in the US. So these are the two parallel technologies, but we are governing through the SDS technology, but both are similar technologies, as I told you. Now the point, why we, I think all of you understand why we move from metallic cables like coaxial cable, twisted pair cable to optical fiber. Are you understand this point or not? Hello,
Yes, sir.
बच्चों,
Yes, sir.
अगर कहीं भी ऐसा तो नहीं कि मैं ही सिर्फ बोल रहा हूँ आप आराम से एंजॉय कर रहे हैं, मैं बोल रहा हूँ यहाँ से, नहीं तो बता दीजिए मुझे। ये क्लियर हुआ आपको?
Yes, sir.
क्या
Yes,
क्या
sir.
क्लियर है ना? क्या बच्चों क्लियर हुआ कि व्हाई वी आर मूविंग फ्रॉम मेटालिक टू ऑप्टिकल? वन लाइन।
सर लॉस कम हो जाता है।
लॉस कम हो जाता मींस 0.2 dB है, एंड another point also I tell you in
हाई
the
स्पीड
optical, optical fiber, you see another point in optical fiber, because this operate at terahertz region, right? And terahertz meaning that 10 gigawatt 12 hertz region, right? And normally coaxial cable, maximum coaxial cable can operate up to the gigahertz, can operate at a gigahertz. In RF world we can use maximum gigahertz, but here means gigahertz means 10 to the power 9 hertz only, and here you are operating at 10 to the power 12 hertz. So what is happening? Bandwidth requirement in the bandwidth, you can say, in the optical is higher, because you know the formula C equals to B log base 2 1 plus S upon N. बच्चों बोलिए, right? This is well known formula for capacity, and you know this is the representing the bandwidth. So, and C is, what is the C means? If you see, define the I, right? So this is the C is equals to information rate maximum. कुछ ऐसा फॉर्मूला होता है ना बच्चों? Capacity, in how you define the capacity? Another formula, rate of information max. डिफाइन करते हो इन इंफॉर्मेशन टेक्नोलॉजी? हेलो, हेलो। देखो बच्चों, मेरे साथ प्रॉब्लम पता है क्या है कि मैं सिर्फ बोल ही नहीं सकता हूँ, सुनना भी पसंद करता हूँ। वन वे कम्युनिकेशन इज डिफिकल्ट फॉर मी। कुछ इसको मतलब समझ रहे हैं? व्हाट इज द मीनिंग ऑफ सी इक्वल्स टू बी? क्या कहना चाहता हूँ मैं यहाँ? एनीवन?
सर कैपेसिटी और बैंडविड्थ का एक रिलेशन होता है, वही।
हाँ, देखिए, सपोज एट फिक्स एसएनआर, in the case of suppose RF means up to gigahertz, RF means maximum you can deal with gigahertz only, right? And suppose you having a fixed SNR, so you can compare the capacity in the case of optical is much higher than the RF. Is it clear? If you having
Yes,
a
sir.
fixed SNR, right? So dear students, and also you know, information we can define the unit bit per second. Agree? So data rate also is higher in the case of optical communication. And this is these 2 points. One is the loss, another point is the data rate. These are the two main things to utilize the optical fiber. Another point here I tell you, a single fiber having a capacity of this single fiber means, right? Single mode fiber. I don't know you know or not. Single mode fiber, right? Having a capacity to deal or you can say support up to the maximum 25 gigahertz capacity, right? And RF signal, RF means coaxial cable like that, they max, sorry, this is the 25 terahertz. And single mode fiber can having a capacity, and that single mode fiber made from the dielectric material, and its diameter 8 micrometer like a hair, you can imagine. And RF channel can handle a maximum capacity of the channel 25 gigahertz. So you can imagine the bandwidth, you can say, right? Because it's a bandwidth. So you can understand the bandwidth of the single mode fiber for RF channel. You can see huge distance here. So we start in 90s optical. इसको बेटा मैं नया निकालता हूँ, एक न्यू फाइल। यार ऐसे क्यों आ रहा, कहाँ पे जाऊँ मैं? चलो, क्या कह रहा है ये? क्रिएट डिफरेंट फोल्डर, वन नोट, चलो डेस्कटॉप पे देता हूँ, नोटबुक नेम, क्रिएट, यस। So dear students, what is happening? Is it clear? In 90s, right? In 90s we have cleared that optical fiber is good one, good choice over the other channels, existing channels, right? So the first come is the first generation, right? First generation, right? First generation. Just a minute, draw. Actually pen thickness is very high. Pen I can use thickness, right? So you see, in it is visible to all of you कि बच्चे बड़ा ही लें
Yes, sir.
साइज उसका। अच्छा ठीक है। इन 90s फिर से कुछ गड़बड़ हुआ, पेन एड, पेन रेड। So we started with the first generation, okay, and that first generation having a laser source, right? Because for optical you require a laser or LED or pin or APD, okay, or fiber. These 3-4 things you require. So in 0.8 micrometer, uh, this what the means of 0.8 micrometer means, this is the central wavelength of the laser source, right? And that laser source that time is built with the gallium arsenide, and this is the laser actually, first generation, right? And maximum bit rate, first generation we have achieved 50 to 100 megabits per second, And this first generation I am talking about, this is around in 1970s. This is the first generation of optical fiber. I am not coming that optical network. I am just only here optical fiber generation, right? And then second generation, and this, and also one more thing here. Here the maximum distance they have repeater distance, right? Repeaters, R means repeater distance, and this is the 10 kilometer. I am talking about 90s, 70s. And then in second generation, they started with the 1.3 micrometer, right? And source, and this source is made from indium, gallium arsenide, or at 1.55 micrometer. This is source made from iron, GaAsP, phosphorus, right? And here data rate is achieved, data bit rate, right? Data rate, BR means DR लिख रहा हूँ, DR means data rate. Here DR data rate is around 10 Gbps, and this is about is 90s. Okay, and repeater distance, R distance, this is around 100 kilometers, right? So I think I quickly tell you why this is happening. Actually, the students at 0.8 micrometer means 800 nanometer fiber, silica fiber, or having a huge loss actually. That is why repeater distance up to only 10 kilometer. But you are moving at minimum loss, a fiber having at 1550 nanometer or 1.55 micrometer, or minimum distortion, right, be having at 1.33 micrometer. Listen to the point very carefully here. 1.33 micrometer, we have a minimum distortion, or you can say minimum dispersion. And 1.55, we have a minimum loss in a fiber. So that is why, according to the requirement, we use these two wavelength, operating wavelength, and we can getting here data rate around 10 GPS and distance is 100 kilometers. Okay, now, dear students, in the here, sorry, one more thing here. Okay, I'm writing little bit wrong. Just give me minutes. Actually, this is the third generation. Actually, dear student, this is the third generation in 90s. Okay, actually third generation. Okay, in second generation, is the second in 80s, right? In 80s. In second generation, we are having 1.33 micrometer, these same sources, GAS 1.55 micrometer, the same sources we having, right? But bit data rate is around the 100 megabit per second to 1.7 gigabit per second, right? And repeater distance, R distance, at 50 kilometer. This is the second generation in 90s, 80s. And third generation, we having a 100 kilometer and 10 GPS in 90s. Then the students, after 90s, right, actual technology started, right? And now in the fourth generation, in the fourth generation, we having a amplifier, double amplifier in 90s, and this is the amplifier known as the EDFA, means erbium doped fiber amplifier. That amplifier is very powerful tool. Why powerful tool? Because its dimension also looks like a fiber. No need to use the semiconductor amplifiers. Because in the third generation, you can see in third generation, we having a 10 Gbps data rate, 100 kilometer, right? Sorry, in the second generation, we having a DR is the data rate 100 megabit per second to 1.7 gigabit per second, and repeaters is 50 kilometer. Reason is that because we require a repeaters, because we do not have a amplifier that is perfectly compatible with the fiber and having a minimum loss. So parallel technology is going on, and in 1990s they have scientists developed the EDF, iridium doped. Iridium is that rare earth metal, iridium doped fiber amplifier, right? And that amplifier in the third generation increase the repeater distance by using this EDF amplifier. So this is the reason to increase the distance from the second generation to third generation, because loss is going to minimum. Okay, now, so now come to the fourth generation, dear students. In the fourth generation, we having a facilities of the large repeater distance, also be having a amplifier, ADF amplifier. Now in fourth generation means after 1990s, now starting here, we have two things. One, in our hand we have a EDFA number one, right? Number two, at that time, WDM technology is started. And this is the fourth generation of the optical network. After 1990s, we have a EDFA with WDM. But in Indian context, we started actual one, 2005. In 1990s, just be replacing the coaxial cable by the fiber cables only. But after 2005, we replacing the coaxial fiber with the fiber, as well as electronic switching replaced by the optical switching, electronic routing we replaced by the optical routings. So these are the features by year wise, right? Now, now in the case of fourth generation, right, after, you can say now, right now 2005, if we talk about 2005 onward, then we having a data rate 10 terabit per second. Listen this point, we having a commercially available, right? After 2005 we having a 10 terabit per second, and repeater distance is 10,000 kilometer. Now you can understand, because if you build the repeaters you require the money, and now if you are reducing the size of the repeaters, you can understand the means cost reduction in the optical communication. So this is the fourth generation around the 2005, and nowadays we are at here in the fifth generation. Okay, so fifth generation meaning that okay, so in the fifth generation, and this, that all the generation I am talking about in the optical communication, not optical network. Note this point: optical networks evolved in 2000, in the fourth generation, or 19 after, and in India in 2000 after. Okay, so this is all about the optical communication generation, not a optical network generation. Listen this point very carefully. Okay, now in the fifth generation we have a Raman amplifier, right? Number one. Number two, because already previously we have a EDFA up to the fourth, EDFA and WDM, right? And then around 2000 in Indian context, right? Frequently used Raman amplifier be having, and also be having a optical soliton. Dear students, this optical soliton actually a technique by which we can reduce the dispersion, means distortion, because nowadays we require a system which having a minimum distortion and high data rate with minimum loss. This is the prime requirement actually. So this is the technology. Optical soliton is the technology which utilized to reduce the dispersion inside the fiber. So in India, we having these all these feature in the fifth generation. So the bit rate or data rate in the fifth generation is 40 to 160 Gbps. Okay, you can think about the optical, RF wireless or optical. You can think about, right? And repeater distance is going to enhance for 24,000 kilometer to 35,000 per kilometer. You can imagine the uh, repeater distance, and this all the feature is not possible to get in normal RF communication. Never is possible. Okay, so this is the reason in India we utilize the optical fiber along with the antennas, or you can say RF word, right? With help of the electrical to optical converter or optical to electrical converter. And also I tell you, satellite communication, suppose we think about in broad sense, satellite communication is not a reliable communication, because number of times in the weather condition you have listening an announcement ki due to the poor weather condition, the signal strength is weak, right? So TV signal is not receiving. So optical fiber, all the continents, right, are in the entire world is connected through the optical fiber cables. Reason is the only because it's a reliable, fast, and with minimum loss. Okay, now come to the point. अरे ये तो बार बार कुछ ना कुछ कहता रहता है. Okay, now come to point WDM. Okay. WDM, right? This is called the wavelength division multiplication. This technology is similar to the TDM technology. Means sorry, FDM technology. Similar to the FDM. FDM, you know, in the analog communication, we having a frequency division multiplication, and in optical we have a wavelength division multiplication. Why? Because this is called the frequency division multiplexing. Now you see, normally in the RF, we use the term for the multiplexing frequency, and in optical, normally we define the optical things in the terms of wavelength actually, right? Because the concept of light, so we define customary in the wavelength terms. So dear student, both are the similar technology. One use, this one use in the RF world, right? Similar working principle, component is change only. Okay, and this WDM used in the optical world, but working principle, both the technology is similar. Now the point ki why we require to WDM, right? Because you know network, if we connect number of nodes in a single channel, then you can say this is the network. Okay, now why we go for the multiplexing? Dear friends, reason is that because a single channel, right? Suppose you see the block diagram of the uh, WDM. This is the post amplifier, right? And this is the channel. Channel means here fiber only, right? And then we having a pre-amplifier, pre-amplifier. Then we having a Dmax, right? Dmax. And these are the channel, right? User end, or you can say these are the input 1, 2 up to n, right? And this is the fiber channel. Okay, fiber. And this portion This portion is nearby the telephone exchange. And this, right. And dear students, this may be is Allahabad, this may be in Delhi. And this distance is 614 kilometers. Okay, or any city. Or in, this is part maybe in the India, and this part may be in the New York. No problem, because channel distance is going to increase, or repeaters, or one thing I escape here. In channel, we also having a inline amplifier, right? Inline amplifier. Okay, this is the block diagram of WDM. Now what is happening? Why we utilize this WDM concept, right? Dear students, actually a single channel, as I told you, it having a capacity around 25 terahertz, right? So single fiber always underutilized, because normally whatever we transmitted, that is not fully utilized actually. So researchers thinks, why not be performing a multiplexing in a single channel on the wavelength division basis, like a frequency division means frequency division basis. We send a number of channel signals inside a single channel. This is the main concept actually. Behind the reason, because the fiber, single mode fiber that the diameter is 0.8 nanometer is still unutilized, because it have a huge bandwidth like 25 terahertz. So we utilize the WDM concept. What is happening? You see here, this is the marks. Okay, this diagram. This is marks, and this is the here D marks. And yes, so these are the channel 1, 2, 3, and n channels here. And these n channel means this number 1 may be having a wavelength lambda 1, this channel 2 lambda 2, and this channel having a lambda n. So may similar way, this is the 2 here, lambda 1, lambda 2, or lambda n. We have sent a signal at different wavelength. Okay. Now you see, I think hello बच्चों, सुन रहे हो मुझे? हेलो?
Yes, sir.
Yes, sir. Yes, sir.
समझ में आ रहा है कि कुछ लग रहा है कि क्या बोल रहे हैं? हेलो? अच्छा ये बताओ, जो लोग बच्चे अवेलेबल हैं, कुछ ही बच्चे मैं देख पा रहा हूँ क्लास में, वो आ सकते हैं क्या हमारी क्लास को यहाँ और फिजिकल मोड में? क्यों? Now see, 1, 2, 3. Now these are the channels actually, and you know the mux operation from digital electronics already you know. Now you see, I have written here, when we pass the signals, right? Lambda 1 channel, suppose this is the Taylor-Ganj signal, suppose this is the Allen-Ganj area channel, lambda 2. Means we are having a different areas, right? Which is covering lambda 1, lambda 2, lambda n, like within a city. And then we marks at a, where we marks? We marks at a telephone exchange, which is located in the Allahabad, in the civil line area. Okay. Now this marking actually we perform in the main telephone center exchange. मैं आपको इसको relate कर रहा हूँ practically क्या हो रहा है actually, right? Now be having a post amplifier. Why not here written post amplifier and at the receiver side, because it's the receiver and this the transmitter. Okay, TX. Receiver side we have a DMAX and pre-amplifier, right? So I tell you what the reason. Post amplifier meaning that we amplify the signal, right? Because some signal is coming from the MNIT to civil line, some signal coming to Sangam area to civil line, some signal coming to airport to civil line. So maybe some losses, and that loss is very minimum, because you know distance is very low. So we required to amplify that loss, or compensate that loss, and this loss maximum 1 dB or 2 dB maximum. So dear students, we prefer here Raman amplifier. Raman amplifier to amplify these compensate these losses which is occurring from MNIT to transmit the signal to civil line area or Sangam area to civil line area. So Raman amplifier type things we have compensated, we have placed in the post amplifier. So post means why called here post? Because before to apply in the input in the channel, sorry, before to apply in the channels, we amplify the signal, and that amplify that signal. This is known as the post amplifier. Now by the single channel, basis on the frequency wavelength division lambda 1 lambda 2, basis on the wavelength sharing, we send inside the channels. And at a receiver end, this receiver located maybe Delhi, Lucknow, everywhere, located far away. As you know, in the digital communication, we require a minimum threshold level, means minimum S by N value, or INSA, ASK, PSK, QPSK, COM, MSK. You remember, we require a minimum threshold level that is sufficient power that can detected by the receiver. Bachos, are you getting my point or not? Hello? हेलो,
Yes, sir.
क्या कहा बच्चों मैंने? बोलो, आपको याद आ रहा है एएसके में, पीएसके, एफएसके भी हैव अ मिनिमम थ्रेशोल्ड लेवल कि इतना होना चाहिए, देन कैन डिटेक्ट द सिग्नल, राइट, इन द टर्म्स ऑफ पावर और इन टर्म्स ऑफ एम्पलीट्यूड. सो वी रिक्वायर्ड अ प्री एम्पलीफायर बिकॉज maybe some 1 dB 2 dB minimum from the, suppose you required at receiver side minus 20 dB, right, but you are having a minus 22 dB. So this preamplifier can amplify 1 to 2 dB, so it can reach up to the 20 dB power. Okay, so preamplifier means this amplifier amplify the signal for reaching up to the threshold value of the receiver. And then this inline amplifier is the EDFA amplifier. Is the EDFA amplifier that can amplify the signal from 10 dB, 20 dB like that. Means huge power it can compensate, huge loss it can compensate, right? So this is the dear students. Now this signal reaching at the demarcation side and then separated in lambda 1 lambda 2 and then can separate it. So this is the actually working principle of the WDM, and this is very similar to the FDM concept. Already I think you know, right? Now another point here, just 1 minute. One more point here. Why not we prefer TDM, the optical TDM? We discuss this point in next class. Okay, why don't we prefer the optical TDM, right? What's the reason actually? Why we prefer only FDM type technology? This is like a WDM. Hello.
Yes, sir.
तो बच्चों कुछ समझ में आया या सब हवा में है सब, एवरीथिंग? कितने बच्चे हैं टोटल? 37 बच्चे हैं, चलो कुछ तो हैं, 100 अराउंड समथिंग. सो बच्चों मैंने आपको कंटेंट्स बता दिया है, क्या क्या कंटेंट्स एग्जामिनेशन के पॉइंट ऑफ व्यू से हैं, और नेक्स्ट वीक भी मैं 1-2 क्लास लूंगा. फिर आपका एग्जाम कब से है? हेलो,
29 से सर.
29
29 से एग्जाम है आपका, और मेरी क्लास तो फिर कैसे हो पाएगी? एक क्लास ले लीजिएगा ट्यूसडे को, या देखता हूँ 1 क्लास एक ले लेंगे आप, और ले लीजिएगा, हेल्प करेगी कुछ. ठीक है, नेक्स्ट टाइम मैं बता दूंगा टाइमिंग्स. ओके, और कोई डाउट हो, कुछ हो, आप डिस्कस करने आ सकते हैं। ठीक है, मैं अभी लीव करता हूँ मीटिंग को। फिर मैं सब भूल गया पहले, इसका रिकॉर्डिंग अटेंडेंस कहाँ से लेते हैं बच्चों, कुछ याद है? हाँ मिल गया, टर्न डाउनलोड आ गया याद। ओके ओके, थैंक यू एवरीवन, नाउ आई एम लीविंग। ओके
Okay, sir. Thank you, sir.